Okay, welcome back to I Can Science That. I'm doing something a little different today. So this is going to be a reaction video. I'm going to be watching a video from DraftScience for the first time and responding to it. This is something I don't normally do, but yeah, I felt like I wanted to do something with it, but I didn't really want to spend a whole lot of time making slides or anything like that. So I hadn't watched the video before doing this recording. I did it in a few pieces, and there are a few edits along the way. Sometimes I'll say things like, "Oh, he's going to talk about whatever." Honestly, it's because I thought I was watching a different video that I had watched before, but no, it was a new video. Watching it for the first time. So these are my reactions to the video. I guess enjoy. And before we go any further, let me give you a warning. This individual that I'm reacting to uses a lot of very rude, hateful comments, a lot of profanity, just a lot of profanity. So this is not safe for children. This is not advertiser friendly, so good thing I don't monetize. But yeah, I mean, proceed with caution. If you don't, I'll swear once in a while, right? So I'm cool with that. That's no big deal. But the kind of behavior you're going to see in this video is not this. It's just not allowed on my channel. You couldn't put that stuff in the comments underneath one of my videos. I wouldn't allow that. Because this is supposed to be a safe space to explore science, right? If you have a contrarian view, if your view of science doesn't match up with my view of science, you're welcome here. You're welcome to come here with your ideas, and I'm excited to explore them with you. But if you just want someone to yell profanity at, that's not allowed. So without further ado, let's watch the video. Hello there. Welcome back to I Can Science That. It's been a while. I've been busy, sort of, frankly, kind of lost interest with a lot of the stuff that I usually talk about. Doesn't seem like there's really any point in having these conversations. So yeah, I just, focusing on work, school, stuff like that. So mostly staying out of it. But this fellow, Draft Physics, made a video commenting on some of my older stuff, and so I just popped in and said, "Hey, this is what I think about this, and if you want to talk about it, we can talk about it." You know how it is. I have this theory that that people sometimes feel like science is dismissive of them, and maybe that drives people away from feeling that science is part of their team, and math is an enemy team or something. And I don't think that's a good thing. I think we shouldn't be trying to push people away, and I think maybe that's inadvertently what drives people to become like that. But yeah, let's take a look at where this has gone, and how this goes when I try to reach out to somebody and try to invite them to have a conversation where I'm not trying to push them away, where I'm absolutely ready to listen to their ideas. I'm ready to test their ideas, ready to get on board. But I got the other side to balance too. So let's have a real productive conversation. Let's see how that goes. So here we go.
Debatephysics.com also, but the people just won't debate, and where you argue with something called evidence, experimental evidence. And so yes, there's just none provided to defend the preposterous fable. And it's just so disappointing that you go over this and over this and over this, and the physicists always do the same bullshit. They talk around the subject and pretend they've answered anything or in any way address the fact that you have no experimental evidence, and that should be called bad science. When you don't have any experimental evidence, that's called bad science. It's great religion, but it's really bad science.
Okay, we heard a couple things there. The he'll cycle back to a lot of these, and we'll touch on them. He wants experimental evidence, and absolutely, I'm an experimentalist, or was right back when I was in school. That was my thing, experimentalist. Yeah, I dig that, and on this channel, that's one of the things I really try to push for is simple experiments that we can do ourselves and cheaply. So yeah, that's what I'm all about. So that sounds good. So why is he ranting against me when we should be allies on that? It is what it is. Because he's characterized then, I guess that's the other thing, he's characterized physics as if it's a religion. That's how he sees things. And it's just not. We'll hear in his own words my evidence for why his point of view is to see this as religion, and I will try to calmly explain why that is not correct. Okay, let's keep going.
Oy. All right, so this I can science that. He can't science to save his life. He's not even close to knowing what science is supposed to be. It's a deliberate, willful investigation. It's detective work. Why is the question you want to answer. Why does it do what it's doing? How does it do what it's doing? How was it done? Yeah, that's what you're supposed to be answering. You're not supposed to be just babbling platitudes of, well, we think a Newton isn't, indivisible into a joule. You can't convert newtons into joules. Well, yeah, you can.
Okay, so now we're talking about some actual science. You can't convert newtons into joules. Those are not the same thing. I mean, they're just not, by definition, right? That we're talking about the definitions of words. If we want to communicate, I think we ought to be using the same words. And a joule is a unit of energy. A newton is a unit of force. Force is not energy. How do I know that? Well, because, based on the definitions of those words. You go look up the definitions of the words in the context that we're using them, which is, physics. They have very, very distinct definitions. They're just not the same. So, I mean, how are we supposed to converse if you won't use the same definitions of words? I don't even know where that's supposed to go.
It's perfectly legal, scientifically. Anyway. Upon request, I have watched only the 5 minutes so far. I will try to find time to watch the rest and review the description later, but I find my patience waning. Well, fine. I'm done. I was, I had patience, but yes, you just keep talking around every fucking subject and keep saying newtons aren't joules. Newtons aren't joules. Doesn't matter. They don't have to be because they can be converted into the same unit.
Okay. Yeah. Why is my patience waning? Because he's very belligerent. He doesn't respond to the things that I say, but instead calls them gibberish. He insists that I'm deflecting when I am directly addressing his points. And you'll see that. And once again, no, newtons and joules cannot be converted to the same thing. They just cannot. Right? What is a joule? I don't know. Why don't we tell you what? Let's look it up. Here we are. What is a joule? A joule is a Newton meter. or a watt second. Interesting. Can we convert a Newton into a joule? Well, if you've got some meters to work with, you can figure out the situation. This is not controversial. This is not difficult. This is just a definition. This is the AI overview. Maybe you don't like the AI overview. There's Wikipedia, videos, Britannica. I mean, I don't know. Just pick one. But this is the vocabulary that is physics. So a joule and a Newton, they are just not the same thing. A joule is a Newton meter. And meters are things. So that's not the same. It's just not.
They have a common denominator. I am allowed to do mathematics with things with a common denominator.
Common denominator. I don't see a denominator here. No. I mean, you're just saying things, right? He's just saying things.
Fucktard. Anyway, 251. You can't do both things. You can't use your momentum in the ballistic pendulum to make heat and then keep the momentum and make motion. You can't have your motion going two different ways. You can't have the motion going over here with a bunch of little tiny things moving and then claim I still have all my momentum. I didn't have to use any momentum to make all that stuff happen. I mean, it's ridiculous mush. It's free energy. If you have 1900 joules of heat and that had to be made with momentum, and you've got 2 joules of motion, then you've got 2,000 more joules of energy than you started with. That's free momentum.
I'm going to probably say it 100 times. Momentum and energy are different quantities, just by definition. And he's saying you can't conserve. Well, what I was referring to there in that 251, he says you can't conserve energy and momentum at the same time. And I mean, of course you can. And my response here is just look up elastic collisions versus inelastic collisions, and you'll get plenty of examples of where we learn this and how we learn this, how we practice with it, and how we demonstrate it in the physical world, that momentum must be conserved, of course, in the absence of an external force. Yes, absolutely correct. And in general, energy must be conserved. Also true. So how can we have both? And it's only possible if energy can be converted from kinetic energy into some other form of energy. And yeah, of course, it's like heat, for example. Heat is the big one. So yeah, and he'll rant about that too.
Oh, fuck. Please look up elastic. This has nothing to do with elastic and inelastic. It has to do with where did the energy go. It's a quantity of motion. It's conserved, which means you have to find out where it went. You have to investigate. You roll a ball on a surface. Only ignorant people think, hey, the ball stopped. The energy was destroyed. No.
Well, maybe ignorant people do think that the energy was destroyed. That's not what I said, and that's not what physics said. Notice the very quick dismissal of please look up elastic collisions versus inelastic collisions. Why do I want him to look that up? He says it's irrelevant. It's not irrelevant. In an elastic collision, kinetic energy is conserved as well as momentum. They're both conserved in what we call an elastic collision. That's what we call that. In an inelastic collision, that's a collision where the momentum is conserved, but kinetic energy is lost, not created from nothing and not destroyed, just turned into heat or other forms of energy. It's used in other ways besides the kinetic energy. That's it. And if you just look that up, you'll see that there's a great deal of background there.
Oh, smart people understand the energy in the ball, the linear motion, was converted into vibrations in the ground. And then those vibrations will dissipate into atmosphere. And then that atmosphere will dissipate it into space.
Yeah, that's what we call heat, right? That's what I just said.
Fucking tard.
Again, so really, I think what we've got here, and it's pretty obvious at this point, that he doesn't want to have a conversation. That's not the goal here, because if he did, you'd find we're in agreement, right? We're in agreement there. The momentum hit something, momentum was conserved. We're in agreement there, and the energy of that motion, went into moving little particles, and the atoms are vibrating, and they bump into each other, and that dissipates. That's what you just call that heat. That's heat. Yeah, and when we're in complete agreement, follows with just a blatant insult. So the insult is the point. That's my only conclusion that I can make here, is that the insult is the point of what he's doing here. I guess we'll go on for a while, see where this goes. I don't know how long I'll do this.
Shit. I mean, to have to explain this to a physicist, you're just like, what the fuck? They really do believe in free energy. All right, the difference between energy and momentum should be demonstrable if it's real. Yeah, well, and you have nothing. Then cite it. I mean, it's just amazing. It should be demonstratable. Demonstrate it. For fuck's sake. Show me kinetic energy doing work. It can't move a spaceship. It can't be collected in a ballistic pendulum. It can't be used on a lever. It doesn't be conserved in pulleys. It doesn't work for a water hose. What experiment exactly does kinetic energy do work in?
All of those. And the irony is, of course, is he's demanding that I show him an experiment, but he won't show an experiment. He won't do an experiment. Of course, I've been interacting with some other folks about this topic, and they show me that they've done the experiment, and they've shown him the experiment, and he just ignores it. And what he'll say? He'll say it's irrelevant. It doesn't count for some reason. He contradicts himself. So once again, he doesn't want the experiment. Obviously, if he wanted the experiment, he'd do the experiment, right? He'd show us all that we're wrong, but he doesn't do that because he doesn't want an experiment. He wants to complain. That's it. He just wants to rant at us. He wants to call us names.
There isn't one simple answer, because it's a fable. When I try to discuss it with you, you reply by calling my efforts all mush. And isn't this mush and gibberish? Is this an answer? The difference between energy and momentum should be demonstrable if it is real. That's your obligation.
Why is that my obligation? Hundreds of years of physics and engineering have demonstrated this. Cars work, right? Cars work, brakes work. The amount of energy that we can put out from the internal combustion engine or from an electric motor, we factor those things in when we're trying to make cars, make them accelerate, race. You hit the brakes and you have to scrub off the energy using friction. And where's that going to go? Oh, it's going to go to heat. How much heat? Better know how much heat you're scrubbing off. It all works. We've been doing this for hundreds of years. It's accepted. Nobody's arguing with it except you. So if everyone accepts that something is correct, except you, that means you need to show us that it's wrong. We've already accepted it. We're moving on. It works. So, you show us. Where's your experiment?
So show me. Amazing. And nothing on the subject. Yes, and you just did more of the same thing. All right. If you want to know how it works from a science classroom point of view, oh, a classroom what? Who you fool with this shit? 6-year-olds? I'm always happy to help. I mean, it's just, I already pointed out you're an arrogant, patronizing motherfucker. Shove it up your ass, Mr. Rogers. Okay. If you would like me...
So there we are, right? He doesn't want to hear what we actually teach in classrooms. He just wants to, yell profanity. And I don't know. Am I going to include the profanity when I edit this, or am I going to bleep it out or something? I don't know. I don't monetize. But at the same time, I don't allow this sort of behavior on my channel. Because that's not allowed. I don't allow globers to insult flat earthers. I don't allow people to come here and say mean things, insulting words about draft physics. If I even post this video, I'll have to police the comments extensively, because I don't allow people to turn legitimate debate into some kind of tribal antics where we rant against each other and call each other names rather than considering the arguments. But why am I making this video then? Really, because I just wanted to sort of highlight where we are in the world today. This is where we're at, where debate about or discussion about physics turns into what you just heard. That's not physics. It's not debate. It's not constructive. What is it? It's just people being angry. and that's it. And that's what's going on with science right now in the world. It's just one guy. It's just fringe. No, it's permeating all different kinds of science now. It's getting into politics. I mean, it probably goes the other way. It comes from politics into science. Hard to say. But when there are factual questions in front of us, and we need to make decisions, make policy based on those facts, it's good to have the right facts. And this is unfortunately very endemic. And what I do with my channel was an attempt to reach out, reach across, as it is said in politics. They say reach across the aisle, reach to people who don't agree. Like flat Earth is a good example. I like to reach out to people who don't believe in the globe and try to show them that no, it's not. We're not a satanic cult. We're not evil. We're not against you. Just you're welcome. You're welcome here, right? You're welcome to learn the things that we've learned. You're welcome to the knowledge that we've gained. And if you don't want it, that's okay too, right? It's okay. I'd hope that when we've gained real factual knowledge, and I'm not talking about some mystical stuff, that's something that's just like written in a textbook, therefore it is true. No, it's things that are actually practical and true, and things that you can build with, right? Like we're talking about now, momentum and energy. Let's build cars, right? Let's build cars. We have an energy plant, that's the engine, and we have a momentum generator, right? That's the motor. We're going to exchange energy back and forth, regenerative brakes. Yeah, let's build that. If you build it based on physics, it does not work. Your engineering will not work. So let's don't do that, right? Let's don't build a society based on throwing out facts that actually work for everyone. But so far, I have not been successful with that approach. My hypothesis has been that people like draft physics here have gotten to this point because they were pushed there. They were pushed away in math class, in science class, probably at the grade school level. They were not made to feel welcome.
To consider an alternative point of view, I'm open to explore it. Go fuck yourself. How about that point of view?
Yeah, once again, very clear. He does not want me to consider his point of view. He wants to have a shouting match about it.
I mean, could you stick your head up your own ass any further? I really don't, I'm not requesting that you try, but, maybe you could. If you want me to accept that you are correct, no, I want you to show me fucking reasons to believe you're crap. How many fucking times do I have to say it? Show me a piece of fucking evidence, you fuck! Okay, let's see. If you want me to accept that you are correct without investigating at all, so that's exactly not what I'm asking you to do, shithead. I'm asking you to explain to me why you believe it. Besides it written in a Bible, what reason do you have to believe the fable?
As I've been saying, because it works. Tried it. In a really good physics classroom, we do labs, right? The students do labs. We try things. And there are labs based on kinetic energy. You just punch up Google, right? Just ask it. What are high school physics labs that teach the principles of kinetic energy? Mathematically, we can do it mathematically. Hopefully, I'm sure we'll hear a rant from him about math because the guy hates math. But yeah, you can just show it mathematically. It's all there, but he doesn't want it. He just wants to shout profanities. That's his whole purpose. His entire purpose, and I'm not the first one that he's discussed this with. He begins with, "Show me why you believe this." We show you why we believe this, and then he just turns into rants, because that's his purpose in life.
I insist investigating a claim before I accept it. Well, you're a liar, because you clearly haven't investigated MV squared at all. Because if you do a little tiny bit of investigation, you'll see it was created by a religious crank and then defended with pseudoscience experiments.
Okay, we're starting to get in here his point of view that science is a religion. When we talk about kinetic energy is 1/2 mv squared, we talk about it. For him, it comes back to who said so. Who is the first person to put this forward? And frankly, I don't even know, because that's not how science works. I mean, that's history. That's not science, right? He talks about Leibniz, and apparently he doesn't like this Leibniz character. Okay, what has that got to do with it? That doesn't matter. What matters is what happens now. In science, we don't go back to the history books and dig that stuff up, and that's not proof of anything. It doesn't matter who said it, when they said it, in what language they said it. That doesn't matter. We've evolved from there. We build on what we've learned from people in the past. And that's what makes science not a religion. Science is not a religion because it's not based on who said it when. It's based on what we've been able to build and prove. And he just keeps ranting that it can't be proven, but there's just hundreds and hundreds of examples, and my very first interaction with him was, of course, suggesting one. I suggested an example that he could do himself, and you see where that has led us.
It's always been a shitty theory. Always. Leibniz was buried a nothing. Okay, he lost all credibility in science. Nobody went to his funeral. No one would pay for it. Newton was buried as a fucking god. All right, if you dismiss everything I say as gibberish, it's not, Show me the sentence where you actually made an argument explaining anything. So give me that sentence somewhere. So was there a sentence you uttered that is anything real?
Of course, that's in the previous email. This email is the one after. He calls everything gibberish. So, yeah, just go back to the previous email. It's full of them. Full of them.
You know, besides tell me what the fuck happened. It's always hitting the wrong button somewhere. Just go back, Gary. Should be works. Back button should work. Please. We're all the way back at the beginning again. All right, so what's this comment? Let's see. I insist on investigating a claim before I accept it. So where's the evidence of that? I'm asking you to show me your detective work. Give me the Columbo.
Very first email I sent you, I gave you an example with a spring. Just do that example. Or better yet, ask one of the very nice people who've been trying to have this conversation with you before me, who have done it, have done the experiment and shown you the data. You know, if you were actually interested in that, it's available, but you're not interested. The truth is you're not interested.
Version of your investigation. Show me where you found some hair and fibers and a piece of bitten cheese and something else, and that's why you've drawn this silly conclusion. If you dismiss everything, so again, it's just, I don't dismiss everything you say, but there's just nothing you've said that isn't gibberish. This entire comment was just gibberish. Where did you talk about the fact that the kinetic energy appears incapable of moving the pendulum? That is, it's incapable of being collected to do work. So your definition of kinetic energy is energy that does work. Well, it didn't do any fucking work.
He's writing quite a bit about this ballistic pendulum. The first video of his that I responded to did have a ballistic pendulum in it. But that part had nothing to do with me, so I didn't respond to that. I responded only to the parts where he was citing my videos, and I've never had a ballistic pendulum in my videos that I can recall. The ballistic pendulum is really interesting, though. If you want to comment, my comment is, of course, it showed momentum, and it also shows kinetic energy. I mean, the words that you say make no sense. Right? When you say the kinetic energy doesn't move anything, and then he's talking about a ballistic pendulum. What is that? You shoot a ball off a spring, like a little ball bearing projected by a spring into a block. The block captures it, and that makes the block swing. So the spring made the ball move. Hey, that's kinetic energy. That's momentum. The ball hit the block. And then it makes the block swing, and that's kinetic energy, and it's momentum. And the momentum is conserved in that collision. Very cool. And it's an inelastic collision. The ball is captured by the block, making it inelastic. And that makes it not conserve kinetic energy. Wow, look at that. That's cool. Yeah, it's all there. But I mean, I don't know. What do you want to know about that? He probably, I'll project the response there would be, I want you to measure the temperature of the block to see how much heat was captured. Okay, could do. Why don't you do it? Right? Why don't you go ahead and do that? Right? That's the video that he shows is, someone showing a high school physics experiment. This is where we can study these things with experiments like these. And whenever anybody says such a thing, we just get these sorts of responses. So it's not about wanting to be shown anything. It's just about wanting a target so that you can make these videos and shout obscenities into the void. That's really all this is.
If anyone is curious about this material, standard physics teaches us that force, momentum, and energy are all different but related. So again, different but related is mushy talk. So you don't see how that's gibberish? They're different, but they're related. They're samey, but they're not samey.
No, that's. I mean, you've got a point there. Is mushy talk? Yeah, because you're offended by my precise talk. When I give you the precision of what is the difference between force, momentum, and energy, and I can lay that out for you in detail and mathematically, you rant about that as well. So this is a simplified summary, is that they are not the same thing. You commonly refer to them as if they're the same thing, and they're just not.
They're a little bit like each other, but some kinds are not like each other. So, one of them has horns, and, one of them has a fluffy tail. The difference between them are measurable and testable. And so he keeps implying there's some evidence somewhere. They tested something, that they dropped 4 pounds 1 foot and 1 pound 4 feet. That they tested this somewhere. They crashed a car, they did something. Where did you do a goddamn fucking thing to test this?
I don't often show experiments being done on my channel. Mostly, I try to advocate for people to go out and do them themselves. The reason for that is because I found that when I show people my results, they dismiss them. They say I cheated and I lied. So, when you're in an adversarial situation like that with someone who doesn't believe you, doesn't want to believe you, they won't, right? They're not going to believe you. So, once again, maybe I'll put a link. I'll put a link to it down in the description. Maybe I'll pop it up in the up there. Somebody showed me that they actually did this. They did the experiment that he's ranting about right now. The one that he's complaining about. No one's ever done it. They did it. They made a video and they shared it with them. So yeah, he's absolutely seen that. We all know he's seen it. That's not the point, right? The point is this performative rant.
God, you're such a shit. I think that pretty much sums it up. Yeah, well, go fuck yourself. So that's his response to a ballistic pendulum. When you shoot a bullet into it, loses 99.94% of the kinetic energy is gone. Missing. It's not in the pendulum. And every single time, with all of our high tech, with all of our fancy physics, we will never push a ballistic pendulum and collect anything more than the momentum. Never do you collect any kinetic energy over the momentum. Not even one little joule. Ever. And
okay. I mean, that's just really easy to test, right? That's just really easy to test. You shoot you get yourself a ballistic pendulum. You don't even, this is so easy. You just touch it with your own hands. It's going to be at room temperature, right? Room temperature. Shoot the ball into the ballistic pendulum. Does it warm up or not? If it warms up even the tiniest bit, then there's your heat energy, right? That you just said doesn't exist. It's there. I don't know. Anybody ever, felt the nail when you've been hammering for a while and you're hammering a nail in, all this momentum with the hammer, bang, bang, bang. Where's it all going? Where's all that momentum going? Why is my nail so hot? I don't know. It's there.
He thinks that's not an indication that maybe kinetic energy is just fucking made up. Oh, fuck.
I mean,
as some asshole chimes in.
It works.
I heard that if a 30-06 bullet hits someone in the neck.
This is somebody else who's responding.
The neck? What a weird.
This is somebody else has something else to say. I had no comment on this. Talking about bullets and shooting, and I'm gonna skip that.
It was an unsuspected surprise, so I'm glad to have it. I haven't read it yet, but we know it's going to be crap. But I just thought, hey. So he answered my 5-year-old questions that are in the description, right? So they're not perfectly worded, but yes, they're good enough questions. All right, if I'm in space and I throw a 2-liter Coke bottle away at 1 mile an hour, And so this is the same as the bullet and the gun recoil. So in one case, I'm going to let the gun recoil fly out of the ship. In the other case, I'm going to let the bullet fly out of the ship. The bullet has 2,000 joules leaving the ship. The gun recoil has 2. All right. Do I receive the same thrust if I shoot a dime away from me at 1,000 miles an hour? If so, isn't this proof against kinetic energy formula? So obviously, I had to generate 2,000 joules of energy to move the bullet. And the question is, how can I only have 2 joules of recoil? How's that possible? So it doesn't obey Newton's third law.
Right. Because those aren't the same units. Joules are not thrust. Thrust is... This is a very poorly worded question, really. I mean, I'm trying to be generous here, but thrust is force. Right? Thrust is force. Force is not momentum, and neither is it kinetic energy. So you're just mixing things up, and you're just saying they're the same, but they're not the same, right? I mean, it's as simple as that. And yeah, let's see what he says when I go through his example.
And it clearly can't be used. It can't do any work. So the energy can't possibly be, you can't possibly have the definition of kinetic energy as energy that does work when I didn't have to do work to do it. That is, if I shot two guns away from each other, right? Had the same explosive and I put 2 guns inside each other's barrel, I'm still only going to have 2 joules and 2 joules. I'm just going to have 4. But then if I make a zip gun and I put 2 bullets in, I'll have 2,000 going that way and 2,000 going that way. I'll have 4,000 joules. Same explosive. So if I measure the power of the explosive, one experiment tells me it's 4,000 joules of energy. The other experiment tells me it's 4.
I'm really not sure what you're talking about there. Explain in more detail, and then we can work it out and see. But the bottom line here is that momentum is not energy, and you're very insistent that it is, but it's just not. By definition, right? The definition of energy is different from the definition of momentum. They are not the same. You can argue that the thing we define as energy is perhaps not effective at something. It's not indicative of something. It's not useful for something. Ultimately, what you're saying is that the conservation of energy statement, the equations of energy are false. And yeah, why don't we stick to that? I don't know.
Now, can you understand that they really need to explain that? Because that doesn't make any sense at all. And the simple truth is the bullet never had 2,000 joules of anything. It's got 2 joules of momentum. But what it does have is a very high velocity that can break things. Like a
momentum is not measured in joules.
Pointy arrow, it can sneak through matter more efficiently. Oh, shit, these people are stupid. All right, so his answer is the kinetic energy formula. No, it's okay. If so, isn't this proof against the kinetic energy formula? Okay, that's the end. I should put a space there. No, it's not proof against KE. So again, I'm arguing, of course it is, because you'll have no explanation for how it's possible that I did 2,000 joules of energy, and yet I only got 2 joules of motion in my spaceship.
Momentum is not energy.
And in the recoiling gun case, I did 2 joules of energy, and I got 2 joules of energy in my spaceship. You can't explain that contradiction. Okay, no, that's not proof against KE. In the absence of a net force, it is a net force. It is an explosion, for fuck's sake. Momentum must be conserved. I mean, this is just baby talk.
When I try to engage with the subject, it's baby talk, right? Right. again, I mean, I summed it up earlier. I don't know why I need to even keep going. It's clear that the only motivation here is to have somebody to argue with.
Obviously, it's not conserved, so there's no point in you saying it. The bullet has 2,000 joules. Where did I...
You know what? Let's let him go.
conserve anything called momentum? All right, your example is a good one that shows that. Oh, fuck you. What your example... So you see, he's just talking around it. What your example shows is that...
What do you mean talking around it? I'm engaging directly with your example with the numbers you provide. I am working your example in front of you, and you're saying that I'm talking around it? Right. Okay, this is where you've crossed the line. You've crossed the line from I'm just a crank, I'm just ranting, you've crossed into like full on lying, right? You're full on lying now. And it's right there on the screen. Everybody can see. Am I talking around the problem? I'm working the problem. I'm like literally working the problem in terms of momentum and then in terms of energy. I'm explaining why those are not the same thing. And that is the topic of conversation as far as I understand it. That's the conversation I'm trying to have. Apparently, it's not the conversation you're trying to have. I think the conversation you're trying to have is that you want somebody to shout profanities at. So, yeah. So why am I making this video? I don't know. Maybe I won't even release it. But I just thought it would be interesting maybe to highlight that, when I come from the point of view of people don't believe in science. And it's our fault. As scientists, it's our fault. We pushed them away. As educators, as communicators, we pushed them into these beliefs. We pushed them away. Maybe that's still true. Maybe draft physics here has been pushed so far that there's no longer any reaching. There's no turning back. He's past the point of no return. But yeah, this is the example. This is the world we find ourselves in now, where we're past the point of no return. There is no more possibility of having a viable conversation with somebody who is against you, right? And yeah, if you're seeing an analogy here, an allegory to something in a more important part of the world. Yeah, that's absolutely how I feel about that. That's what this is. This is an allegory to politics. Yes, it is. Science and politics have blended, and yeah, that's where we are. Where we can't pull people back across from another point of view. Can we maybe start over? Are there young people today? Can we prevent young people from getting pushed that way? I still think maybe. There's something there, but certainly my efforts have shown that this is the fruit that my efforts bear. Yeah, right. Let's keep going.
That throwing a 2-gram object at 1,000 miles an hour takes more energy. Right, exactly. Where did the energy come from?
You threw the object, so the energy came from your muscles, right? It's the chemicals in your muscles. It's a chemical reaction. I don't know. I mean, what more do you want?
Where did it come from? I did 2,000 joules of work and to produce the bullet, and I only got 2 joules of rebound.
A little unrealistic to imagine that you threw an object. No, I guess I'm sorry. The Coke bottle, it came from your muscles, right? You said you throw. My bad. You shot a dime. So in that case, I'm presuming you said shot. I don't know. What is that? A gun? Something analogous to a gun. You're shooting a dime. So I don't know where you got the energy from. Probably chemical. Again, it was probably a chemical reaction caused that. Could be chemical by way of electrical, right? Or maybe it's just like a capacitor you used. I don't know. That's where the energy came from.
So how is that obeying Newton's third law?
How is it not? How is it not obeying Newton's third law? Which I'll have to rewind and see. Maybe it was a different video, but you were ranting against Newton's third law earlier. Right.
Explain it to me, please. Throwing the 2-kilogram object at 1 mile per hour despite it being the same amount of momentum. So, yeah, that's no point. Momentum is not energy. Again, you keep saying it, but prove it. Prove it doesn't move things, makes things, and give things force. Prove it.
Okay, I'll prove it in the very next 2 lines. Next 2 lines is the proof that momentum is not energy. I invite everyone to look at the next 2 lines. They're on your screen. Let's see if you can follow along.
Prove it. It doesn't perfectly fit the definition of energy. Energy is motion. Momentum is motion. I mean, amazing bullshit. Energy comes in units of... He's doing it again. It doesn't matter if it comes in Newton meters, because I can convert that into joules. So fuck you
Yes, you can. A joule is a Newton meter.
again. Momentum comes in units of ns. It doesn't mean anything.
Does he know what ns is? I'm not sure, actually.
Since meters are not... Oh, fuck you. It's just,
Okay. So there you are. I put it to you, dear viewer, that is proof. Momentum is not energy. Energy comes in units of Newton meters. Momentum comes in units of Newton seconds. Meters are not seconds. So Newton meters are not the same thing as Newton seconds. They're just not the same thing. What more do we need? That is proof. By definition, the definition of energy is different from the definition of momentum. Those are different words. They mean different things. So you could perhaps argue that the kinetic energy formula is not correct. Okay, I was willing to entertain that. I'm willing to experiment with that. But to say that the words are not the same, right? Those words are not the same. They have definitions. That's all. That's right. And if you can't even agree to that, then we may be at an impasse.
So no answer. Is there any physical evidence defending the kinetic...
Wait, no answer? Wasn't that my answer? My answer, once again, in case you missed it, was that momentum and energy cannot be the same thing. They don't have the same units of measure. It's like saying inches and degrees are the same thing. They're just not. We measure them differently. Meters and seconds are not the same thing. I don't think anyone would argue that they are. But you seem to be doing so, right? The definition of energy is newtons times meters. The definition of momentum is going to be newtons times seconds. Or certainly that's one form that we can put it in. We cannot convert seconds into meters. So yeah, that's not going to work.
Kinetic energy theorem. The theory says an 8-pound bowling ball will produce twice as much energy as a 16-pound ball throw with the same effort. No pro bowler can make the lighter ball work. Why? Okay, and he says, answering just the first part. Well, fuck you. Yes, of course.
Yeah, forgive me, I don't know anything about bowling. Sorry.
We do this in physics classrooms. No, you don't. There are lab experiments we do as students to verify this. So he just keeps saying it.
In the first video, not first video, sorry. Strike that, reverse it. Again, in the first email that I sent, I gave an example of how to do this with a spring. Just a spring launching thing, like a pinball machine type of thing. You could do it with a pinball machine, literally. So, yeah, that's the example that I gave. And also there's another creator who went and made a demo again with springs. We could do this in any number of ways.
No, there isn't. You're a pathetic liar. Okay. I invite you to try one. I invite you to label one of them, show me one of them, link me to one of them, you lying sack of shit.
So yeah, again, with the projection of lying, let's make sure I'm not a lying sack of shit. Here's that first email that I'm referring to. I wonder, here's my explanation of how you can do this with a spring. Do a little, experiment. And here's a link to the product that I suggested that you might look into. And you say, oh, we don't do this in physics classrooms. No one's ever done this in a physics classroom. Then why do they sell this product? What is this product for? If it's not for physics classrooms, gosh, I wonder. So yeah, here's a spring and you can launch your little steel ball. And you could dig deeper. I'm sure you can find the one that we had in my physics classroom when I was a kid. We had one that had 3 different balls. And we had one that had 3 different kinds of balls. And so they had 3 different masses. So the spring would launch with the same amount of energy with the 3 different balls. And you can just measure what the launch velocity is for each one. And you can measure the height that it goes to. You launch it straight up and see how high it goes. All kinds of fun experiments that you can do with this. And regularly done in the physics classroom. So, it's kind of funny, who is lying about this and who refuses to do experiments, right? That's an example, right? There's much more.
I suggest one to you earlier. Where did you do that, liar?
Very first email, just showed it. Everyone saw it. So now we know, right? We know that one of us is lying, right? Yeah, okay. I could see that point of view. Sure, one of us is lying, and we all just saw the receipts.
I can offer you several more. See, there's nothing here. He's implying that there's some video he offered. Where is it? You didn't offer a video showing me kinetic energy doing any work.
I didn't offer video. I linked you to a device you could purchase and use it to do these experiments yourself. If you would like a video, someone else, a different creator, has shared one with me after having shared it with you first. So we all know, we know where this has led and where it leads from here.
Pathetic liar. You didn't show me a 1 mass going 2V doing more work than a 2 mass going 1V. Show me that. I pointed out how regenerative braking. Oh, fuck you. Regenerative braking has nothing to do with this subject.
Right. So there we go again. Regenerative braking has nothing to do with conservation of energy. How do you figure? How do you figure that using the momentum of the car to recharge your batteries, right? That's regenerative braking. The brakes turn the motor and generate electricity. That electricity is stored in the battery. That's energy, right? We're capturing energy. And if this works according to physics, then it's capturing kinetic energy. Batteries don't store momentum. Batteries store energy. So there it is, right there, straight up, exactly what you're asking for. Obviously we're way beyond this now. But had we been in a collaborative point of view, I'd be happy to film some experiments, do some experiments, take some measurements, set up an accelerometer in the car, and videotape various regenerative braking decelerations from different speeds and see how they differ and see how you can do that. if anyone out there thinks that's really intriguing, yeah, I mean, I guess if anyone else cares, we could go into it, but it's quite obvious that Mr. Draft Physics here does not care about that. He insists that only acceleration, not deceleration. No, braking is no good. He insists it must be the accelerator that we measure. I'm like, okay, I mean, whatever, right? Do we not understand that that's the same thing? Okay, right? Whatevs. We could do that too, right? We could do that too. It's the same deal. Have you noticed that your car accelerates more rapidly at low speeds than it does at high speeds? I have noticed that when you slam on the gas, when you pedal to the metal there, right? From a stop, your tires spin. You got to let off a little bit, right? To get maximum acceleration. Whereas once you're rolling, you can probably floor it and the car does not have the same amount of get up and go. Why is that? If the battery and the motor are producing momentum, then the rate we can increase momentum should be constant regardless of what our speed is. But that is not the case. It's just not. This is basic engineering, basic physics. And if you've ever done any kind of engineering with cars, you understand that the car's acceleration drops dramatically as you get higher and higher in speed. And there's a few contributors to why that is, but the biggest one is the power problem. The engine is producing energy, and the energy has this component in it that scales with the square of velocity. So yeah, that's that, and it's pretty obvious that you're not interested in having that conversation. You're just pretending. You're pretending that you're interested in having that conversation. All right. I mean, I'll still have the conversation here in this video, at least the rough explanation. If anyone finds this interesting, if anyone is genuinely curious to see demonstrations of that, or derivations, will work math problems, anything you're interested in, down in the comments, ask a specific question. We'll get into that. Draft Physics is clearly only interested in having someone to yell profanities at, and this will be the last one of those where I'll participate with him on that. This is just here to show you what we've devolved into in terms of having a conversation with someone who has been pushed so far that they're no longer open to even discussing this.
Oh, he's such a weaselly cunt. All right, why did it do this? All right. My bad, I hit the button. Oh, it's just so bad. All right, as I pointed out how regenerative braking works in EV, I mean, this is just baby talk. Yeah, you're reversing the function of the generator. How does this have anything to do with the subject of an 8-pound bowling ball and a 16-pound bowling ball? How are you on the subject somewhere?
Wasn't the subject energy and momentum? What do you think regenerative brakes do?
I can document to you a 16-pound ball going 8 miles an hour and a 8-pound ball going 16 miles an hour, and I can document that they'll knock down the same amount of pins.
Is knocking down pins how you measure energy, or is that how you measure momentum, or is that how you measure knocking down pins?
They'll give them net. When they're all done, when all their energy is exhausted, they will have the same amount of mass moving. The pins will be the same amount of mass moving. I described how car acceleration is power limited. Oh, I mean, fuck. I just can't believe how dishonest this weasel is.
Yeah, and that's how these conversations devolve. I think we do it. Probably we do it on both sides. We see someone who doesn't agree with us and immediately jump to dishonesty. or the similar phrase, intellectually dishonest, we'll say sometimes. Yeah, I think there's a interesting philosophical question: is draft science? Is draft physics? Is draft physics lying to us right now? In my opinion, yes. Yes, he is, because he knows that what he's saying is not true. And yet I understand that that there's something going on with his way of reasoning to where he's absolutely certain that he's telling the truth. He's both. He's both certain he's telling the truth and also fully aware that he's not. That's the truth of it is that's how humans do. We can do that.
He doesn't think this is a gobbledygook bullshit answer. Fuck. If I shoot two objects with inverse velocity to mass ratios, so this is the 5 mile an hour vehicle turned into a 10 mile an hour with the extra weight, and you lose half the velocity. Into gravity, your formula says one object will have twice as much energy as the other at liftoff. If I let the objects fall on an identical spring, they will be recorded to impose the same pressure, the same joules of energy. How do you reconcile the fact with your theory? Or
pressure and energy are not the same either. Pressure is not force, but I'm going to infer that he means force.
Do you dispute the fact? So he says, let's say 10 kilograms at 5 meters per second, so 50 kilograms of momentum. That's 120.
Let me just pause you right there. 50 kilogram meters per second. Okay.
25 of energy. So he's just doing the calculation. We already decided that there's this the objects have the same momentum. We don't need your calculation. We already know it's the same momentum, and one of them has twice as much kinetic energy. Why are you doing this bullshit?
Well, once again, let me just highlight this is me taking through with great care his calculation and showing that his calculation is right, that they have the same momentum. We're in agreement, and they have different energies. We're totally in agreement that far. That's me emphasizing that. And this is how we know for a fact that draft physics is not interested in having any kind of conversation, right? He's going to be arguing with me while I agree with him. This is amazing.
Those will not compress the spring by the same amount. Try it out. So again, no, you show me the counter experiment. You show me. You try something out, you fuck. You've had 350 years of preaching your religion. You'd think you'd have a single shred of fucking evidence? God, what a pile of crap.
Again, that's the exact experiment. That's literally the exact experiment that I had shown to him with that link. The springs, the little spring gadgets that you get, that you can get for physics classrooms. And I'll say it again. There's, another creator has done this where they dropped. I was suggesting shooting them. I thought that use the spring to shoot the balls up would be a great way to demonstrate this. That was before I had read this. And now I read this and I see, oh, well, he wants to drop a mass onto the spring and measure that. Turns out someone has done that. I'll be sure to link that down there in the description if you guys want to see that indeed someone has done this and shown it to him. And yet here he is ranting with the same rant, pretending that he's never seen the experiment. Just literally playing pretend that pretend this has never been shown, when many of us have come along and insisted that this is regularly shown in high school classrooms. You could do it yourself. You could build your own. You could buy some stuff. Not very expensive. A few $100s worth of gear. You could do this. But but he doesn't want to. And if someone does take the bait, right? If you take the bait and you go to the effort of reproducing the experiment, it's not going to move the needle at all on this conversation. So, what's the point? Those of us who did it in high school, fun. We had fun doing it in high school. Frankly, we didn't need to be convinced. We were ready to believe that the past 200-300 years of physics has been borne out in modern engineering, and people that go on to engineering degrees. We design things based on these principles, and things that we design and extensively test, they work, right? So we're convinced. We don't need to be convinced. The only one who needs to be convinced, apparently, is you. And you're not willing to do these experiments yourself. You insist we must do it. But of course, that's a trap. If anyone takes that bait, it's not going to work.
Springs store energy, not momentum. Where did you prove that? Show me that experiment. That experiment must be somewhere. Show me. This is an excellent example. What example?
This is the one you just described. Your example of dropping different masses with different velocities onto springs. Do that, right? Just do that and show me. How do I know that springs store energy? When I first encountered this guy, I didn't really remember, to tell you the truth. I had to investigate it briefly. It turns out it's not that hard to show, right? It comes from Hooke's law. You can go straight from Hooke's law and combine that with Newton's second law. Newton's second law and Hooke's law together. You apply those with, maybe a little bit of calculus if you can handle that, and you integrate that, right? You integrate a little bit. So there's some math, and you come out with, oh yeah, that's energy. Okay, right? Right? It's that's what I did. I mean, and then I looked it up and verified that, my equations were correct. And in high school, we didn't know how to do all that stuff, probably. So they usually just gave you the equation. And so the equation for the energy stored in a spring is, if I remember right, 1/2 k dx squared, right? Or the displacement. Take the displacement, square it, 1/2 times the spring constant. That's how much energy is stored in the spring. I believe that's right. And I don't know. Let's look it up, right? There we are. Yeah. That's the same equation that I remembered from, I would say I had the memory of a goldfish. I did this just 2 days ago, probably. Got out a piece of paper, did my little integration. And that's what I came up with. That's the energy stored in a spring. So yeah, if you squeeze a spring by amount X, this is how much energy is supposed to be in there. It's not momentum. That's energy. So yeah, that very example, that very example that you suggested is a great example. Why don't you just do that, right? Why don't you just do it?
Do the experiment and show us. No, you do it and show us. You fuck. God.
Well, as I said, that's just bait, right? That's just a trap. He won't accept it. It'd be, well, we always had this imagination. In our imagination, we're like, oh, I got him now. I got him. He's said right now that if we go to Antarctica and we see the sun circling around our heads, that would prove, right? That would prove the Earth is not flat. So we're like, okay, let's do it. Right? Let's do it. And then some guys, they go and they do it, and they spent hundreds of thousands of dollars, go down there to Antarctica and film the sun going around their head. And, same outcome here, same mentality, same outcome, which is, I don't believe you. You show me. I'm not going to do the experiment. You do the experiment. prove to me that it's correct. You do the experiment. Do they change their mind? No, this is usually what happens. They say that it's never been done. Usually they say, no one's ever been to Antarctica, right? No one's ever seen 24-hour sun. No one's ever seen a 24-hour sun in Antarctica. No one's ever dropped a mass onto a spring and measured the displacement. Like, just imagine, right? Imagine that no one has ever tried dropping a mass onto a spring and measuring the displacement. Sure, they haven't, right? Sure, they have never done that. But you're going to scream about it. You're going to scream about how no one's ever done that. But of course, you're not going to do it. You're certainly not going to do it.
I can't stand these assholes. You're the physics. Physics has all the money, all the equipment, all the labs, all the everything, and you've done nothing with it. You blow up watermelons. You don't do any fucking science, you weasel. God damn it. Or simply watch someone else do the show me. Link me to your evidence, fucker.
Yeah, that'll be down in the description. He's seen it before. You all know it. You know. It's okay. You know.
How many fucking times do I have to say that? Link me to your evidence, motherfucker. God damn it. What the hell was just on this screen? Yeah, I don't know what that was. Weird. Somebody's hacking my tablet. All right. Do you think a 5-ton, 10-mile-an-hour train can do twice the work as a 10-ton train going 5 miles an hour? So simple enough. They have the same momentum. One of them has twice as much kinetic energy. Let's see what his answer is. So he says yes.
Yes.
They won't show it. I plow them into a ballistic pendulum, they'll do the same thing. All I get is the momentum. I plow the 5 mass going 10 into the ballistic pendulum. I throw the 10 mass going 5 into the ballistic pendulum. The ballistic pendulum does exactly the fucking same thing.
Does it though? Did you show that?
Show me your counter evidence.
Did you show that?
No, he's such a
I missed it if you showed
piece of shit. Work is defined to be energy with units of Nm. Nm. Momentum has units of Ns. Ns. Those are not the same. Mature. Yeah, so he keeps playing a game with the units. Everybody knows you can convert Fahrenheit into Celsius, and you can convert both into Kelvin. No, it's not an issue.
That's right. You can convert Fahrenheit into Celsius. You can convert both into Kelvin. Can you convert meters into seconds? Let's hear. Let's hear how. How do you convert meters into seconds? I would love to hear that one.
You lying sack of shit. All right. It's literally just the definition of the words here. I'm unclear why you would want to argue about it, because it's two different kinetic energies and they'll do exactly the same fucking work. And that's the whole point, jackass. You're saying they'll do different amounts of work. Well, why don't you show me the experiment where they do different? We all know they won't do any different to the ballistic pendulum, because we know the ballistic pendulum is just going to collect the fucking momentum and that's all it's going to see. So you show me the fucking experiment where the kinetic energy reveals itself.
I don't know. And then no need to respond.
Oh, God, this is so dishonest. Do you think you can create heat or deformation and transfer 100% of your momentum to another object? So this is just the simple consequence of the previous question. If you think there's heat and deformation when I combine two masses and make a bigger mass, then how did I keep all my momentum? I can't make heat for free. I have to use momentum to make heat. All right. So he'll again, he's just going to evade the subject. Perfect transfer of anything is extremely. We're not talking about perfect. We're talking about 150%.
No, I'm not. Again, I'm not evading anything. I'm literally answering your direct question. You said, "Can we transfer 100% of your momentum?" And that would be perfect transfer, 100%, exactly, right? And I'm saying, no, I mean, you're not going to get 100%, but you can get really close.
200% or 400%. We're talking about
No, you can't. You can't get more than 100%. Always under 100%. And the same is true for energy, right? This is the whole thing he doesn't understand. That you can transfer up to 100% of your kinetic energy to another object, right? The rest of the energy got to go somewhere. Usually goes to heat. Don't forget sound. There's deformation. Those are some big ones. So yeah, you lose some energy. You're going to lose some energy. And let's see if he reads the rest.
having momentum go over here, and we know the momentum can just be considered heat. You have heat over here, and then you have heat over here.
Momentum and heat are not the same thing.
And it's twice as much heat that you started with. You started with a certain amount of motion. You now have twice as much motion.
Never happens.
Mass moving. You can't do that. You can't make free momentum.
No, momentum must be conserved.
Oh, fuck. He's just such a... I would never ask for 100% out of any physical experiment. Well, guess what? Some of them do have 100%. Some of them are just that good. To see examples where kinetic energy is transferred almost entirely to another object. Okay, great, thank you. I suggest steel pucks. They're the same fucking mass!
Who said so? Who said that all steel pucks have the same mass? Where did you get that idea?
Oh, God. If you don't change the mass, it means you don't change the velocity, so you can pretend then. It's okay to pretend you started with v squared and you end with v squared, because you're not going to change the fucking velocities proportional to the mass. So you can't change the mv any. So it doesn't matter. We're talking about experiments. I've made it explicit so many times. I mean, fuck you. This is just such bullshit. Do it with different massed pucks and then tell me you conserve the kinetic energy.
That's what I'm telling you.
Because that's essentially the ballistic pendulum, asshole, and you know it.
No, you see, the ballistic pendulum, read on, that's inelastic, right? The ballistic pendulum example that you were showing in that other video was an inelastic collision. I'm asking for an elastic collision. Thank you.
If I have a half mass puck and a full mass puck and I smash the half mass puck into the full mass puck, I'm just doing a ballistic pendulum experiment. Whether it's elastic or inelastic won't matter.
It matters.
Because I won't conserve the kinetic energy.
You never conserve it all, but you can get higher than zero.
All right. So let's see. I suggest steel pucks on an air table. Certain steel alloys have high coefficient of restitution. Yeah, glass works too, jackass. But anyway, okay.
Again, I just got to point out the irony of him calling me names for suggesting steel, because clearly he has not read the following sentence. So maybe you see it. Maybe you see the sentence is already there. It's already there.
What does that have to do with anything, you fuck? Oh, we all don't know. I could use a silicate. It might cost $50, but you could use, some kind of silicon-based. You need a material with CR as close to 1 as possible. Yeah, Newton talked about this. He found glass better than steel, but, steel back in Newton.
It depends on which steel you use. As I was looking this up, and I did look this up, your average steel is much less than glass. It's really kind of not that great in terms of coefficient of restitution, bounciness, right? Steel is not as bouncy as I remembered from my physics classes. In physics, we did this with steel because, right, we did these experiments in my classes. And I remember it being very, very bouncy. It turns out there's different alloys of steel, and some of them are made for this purpose. They're made to be very, very bouncy.
It wasn't all that. Glass and ice are more readily available, but tend to break if you're not careful.
There you
So
go.
again, this is just baby talk. This is just talking around. This subject isn't about what materials you use, you jackass.
Yeah, yes, it is. It is about the materials that you use. If depending on which material you use, see, here's the thing. If those of you who didn't get this far in physics class, or you don't remember, probably more likely don't remember, right? Because that was high school, am I right? Um, when things collide, there was this whole unit. We did like a whole unit in physics class on this, where when they collide, you have to calculate what is the, if this is the input velocities, what are the output velocities? And what you find right away is that conservation of momentum doesn't give you that answer. You get an infinite number of solutions to the problem if all you do is conservation of momentum. Conservation of momentum doesn't tell you what's going to happen. It only tells you the range of possibilities, and there's an infinite number of answers. So in order to choose which answer is correct, we need to know the elasticity of that collision. Either give me the coefficient of restitution, or more likely they just told us it's either perfectly elastic or it's perfectly inelastic. And then we worked the problem from there, right? Those of you who remember, maybe it's back of your mind, maybe you remember doing this. Or if you've never done it, that's the topic to look up. That's where you learn this material. In order to get a concrete answer for the result of a collision between two objects, conservation of momentum will not give you a single concrete answer. You need to know how much of the energy is also transferred. Right? And if you transfer all the energy, we call that elastic. And if you transfer like none of the kinetic energy, only the minimum amount, which is needed to move them together as a single mass, then that we call that inelastic. That's it.
You could just put springs on the fucking puck. Oh, you're such a fuck. For an example where the kinetic energy is transferred almost entirely as heat, maybe shoot something into water. Well, there you go. Maybe physics should have done that experiment, huh?
Imagine a world where no one's ever tried this before. That's the imaginary world that this person seems to live in.
Maybe in all 350 years they should have done that experiment, right? Joule invented the Joule tank. Show me where there's a modern scientist still using it. Why aren't they using the Joule tank?
Because we solved that question a long time ago. And no one's thought to question it to this extent. No one really has encountered someone who looked at all the other examples that we have and said, no, I don't believe those. I want to do this other version. I'm offering, you could do it. If you don't believe it, go for it.
Why aren't they doing exactly that? I mean, Joule was a fucktard. I mean, the only way he was using his Joule tank was dropping shit on a string. That's not a great idea. Okay, that's not. You people think that it doesn't matter how slow something falls in gravity. Well, it actually does matter. Oh, you're all so dumb. Anyway.
And we see there another example of the religious approach to science, where it's not about what is the scientific principle. It's not about how we applied this in modern times. It's not none of that. It's just I read about the history of a man named Joule who did an experiment and somehow came away with that after having read about Joule and his experiment. This person has apparently come away with the impression that that's how we are taught physics, that we are taught about something somebody wrote 300 years ago, and then we treat that as gospel. That's not how it works. We're often not even taught, or maybe somebody will mention, right? Somebody will maybe mention the history of an experiment or the history of a principle and talk about the pioneers who originally came up with it. But really, we don't care. We name units after them. We name formulas after them. Cool. Like Hooke's law. Great. I mean, as far as I know, Hooke was kind of a jerk, but that doesn't mean he didn't do experiments with springs, and that what he found is still valid today. We all use springs. We design machines with springs, and we use Hooke's law for our springs. Yeah, sure. We measure energy in joules, right? And sure, it doesn't mean we worship Joule or we refuse to question these things. We learn the principles that people have discovered before. We test them to verify they're correct. We use them in our engineering practice. That's how that works. And we do lots and lots of engineering based on these principles. And if an engineer discovers that one of these principles is not holding, that turns into a paper, right? That turns into a paper we're going to write when we discover something doesn't quite hold. And that goes into the scientific journals, goes into the engineering, publications. And that's what research is, right? Right? It's not religion at all. And most of us, including myself, we don't really know that much about the history, who these people are, or why they did what they did 300 years ago. I mean, whatevs, right? It's kind of interesting, maybe from a history standpoint, but that's not science.
For example, where the kinetic energy is transferred on the other side, maybe shoot something into water. As water absorbs motion, measure the rise in temp. I can't believe this bullshit. Again, he's telling me that I need to do the experiments. They don't have to. He doesn't have to prove his religion. I have to prove mine.
I don't have a religion.
It's just a gross double standard.
I don't have a religion.
The ballistic pendulum you mentioned is a fantastic example of yes. So he's going to try to argue that it's a fantastic example of what? The complete failure of kinetic energy to do anything called work. Oh, he's such a lying sack of shit. You'll need to measure some temperatures. Well, that's your job, right?
No, it isn't. No, my job is not to argue with a crank on the internet. That's not my job. My job as an educator, my actual job, is to provide young engineers with the knowledge that we have gathered, and to give them practice with the tools that we have available to us today, that kind of thing. In my practice in teaching, it's software. So we don't do physics experiments. We don't do that. What we do is we teach how to simulate, right, in software, how to simulate reality in software. So I'll teach the equations, show the equations, and then show how to program those to get a simulation that looks like reality, right? And if it doesn't look like reality, it's not acceptable. If it doesn't match reality, it's not acceptable. So it has to be based on equations that match reality. And that's what my job is, to help people learn where those are, and more importantly, to learn where to find that information. Because one of my big mantras in my classroom is not to try to memorize these things. It's not about memorizing. It's about understanding how to apply principles and knowing how to go and find reliable reference material. Like go find reliable reference material so that you don't have to memorize what the energy stored in a spring formula is. It's not going to be on my final exam. If you want to know, if I ask you to simulate a spring, which I might do, I have done, simulate a spring, you're going to need to know that. And so what are you going to do is know where you can find reliable information on that. And frankly, I'll tell you where not to look, right? Or you can go and find some very incorrect information, and you do have to watch out for that. On the internet these days, the signal to noise ratio on the internet has always been bad. It's getting worse. So that is one of the big challenges that we have to watch out for. As long as I'm off on a tangent here, one of the exam questions that I do give is, and maybe it's a little mean, but I ask the students to simulate something, and I tell them, what the name of the principle is, and then they go and they Google that principle and they find a tutorial on it and follow it. And yeah, that's allowed during my exam, to go and find reference material, because that's what I'm really teaching, right? How to find good reference material. And that's really the exam. It's kind of a trap, because if you Google it, the first hit you get is wrong. They've got a mistake in it. And I am asking the students, I'm testing them. Can they find that mistake and adapt to it? In software simulations, it's a common problem. The published information, particularly on the internet, is often inaccurate or incomplete. There isn't a whole lot of motivation for us to publish our final results to the internet. So, yeah, and it's a fast-moving field. So we're doing lots and lots of people are creating lots and lots of simulations of things and doing lots of research to get that to work. But most of us don't bother to publish the final results. We'll often publish our halfway results when we're like, oh yeah, this is what I'm working on right now. And, we'll often publish that. And then we'll put our heads down and really finish it. And by then, it's done now. I'm not going to publish that. So, that's a problem. Anyway, tangent over. Let's see where even he was.
They've done hundreds of videos on YouTube. Not one of them stuck a thermometer in the fucking pendulum. Not one.
Why don't you do that? Go for it.
All right. To assess how much heat is absorbed. Right. Yeah. So why didn't Professor Lewin use a thermometer?
He wasn't measuring that. Right? It was your idea to measure that, not his. Why don't you do it?
All right. And watch out for the heat being dissipated while you're trying to measure. Maybe insulate it first to help. Yeah. Fuck you. There's absolutely no evidence that the pendulum even gets warm to the touch. So fuck you.
I don't know. I mean, I know that nails get hot when I hammer them. I've definitely noticed that. Anyone who's ever built anything with nails and a hammer would agree. Nails get hot. And I used to think, oh, that's just friction, right? It's just friction. And then somebody pointed out, no, it's not. Actually, it's because you're banging on it. You can just bang on things and they get hot. That's known. It is known. Try it.
Overall, I see you asking lots of questions here, but it doesn't really seem you've tried very hard to find answers. It's not my job to prove your theory. It's your job to prove it.
Prove it to who? Who? My job to prove it to you? Good luck with that. No one can prove anything to you because you won't accept any form of proof. If it is my job to prove it to the students in the classroom, then I ensure that I get that job done, right? If anyone has questions, we'll go into it as far as we need to go. As far as someone who is truly inquisitive that wants to know, we'll go as far as we can. I always say I could take you from 1 + 1 = 2 all the way up through this stuff. It may take quite a while, right? It probably took me, 15, 20 years to make that progress. But I think we can go a lot faster, right? We can skip the stuff that we all agree on. If we can all agree on addition, subtraction, multiplication, we can skip that part, right? Whatever we agree on, we can skip up through that part. But you can't just skip over the parts you don't like and then say that they're false, that's all you've got, right? You say, no, that's false. Prove it to me. And then when someone patiently sits down and says, look, let's go through these principles one by one, step by step, until we get there. you just say it's gibberish. You say it's what else? You say is evasive, and you call us liars, right? So that's why that's where we are, right? This is the reality of science denial. In probably always is probably human nature, part of human nature to be this way, and the internet just gives us a way to express it.
I'm asking you to show me some fucking evidence, and you can't manage some real evidence. Not little denting clay with round objects, not gimmicks.
Right. The irony, right? The irony. As he says, show me some evidence, he immediately follows it with an explanation of some evidence that he has already seen and has already decided to reject, right? Dented clay. I don't even know about the dented clay thing. This is apparently something he's read about from science history. I don't know about that. It's I'd be happy to hear about that. Maybe even hear about why that's not good evidence. I don't know. But yeah, the irony of screaming, show me some evidence. Oh, and not this other evidence, right? Show me some evidence, but not the evidence that I already have. I need evidence, but not that evidence. It's amusing to me.
Overall, I see a question. I have some answers for you right here. Yeah, fuck you. Not even close to an answer. I will now sit back and wait to see how you react to those answers. They're not answers. You didn't say a motherfucking thing about any of the subjects. You didn't explain how you can knock more pins down with the same momentum.
I'm sorry, I'm not up on bowling, but I did talk about springs. I talked about generating power in a battery, right? Talked about those. Talked about heat, momentum, energy, electricity. I'm sorry, I don't know about bowling. It's not my thing.
I have two bowling balls. One of them has twice the momentum. Twice the energy, but they have exactly the same momentum. I went through the whole calculation. I mean, when they hit the pins, they lose the proportional amount of momentum. So if the pin leaves with 4 units of momentum, the ball lost 4 units of momentum. So there's no way to make it any different. There has to be the same amount of pins moving using both balls. It doesn't make any difference. And that's why bowlers don't use 8-pound bowling balls, is because it's not twice the energy.
Again, conservation of momentum, not a new concept, not in dispute. We agree with conservation of momentum. That's a thing.
It's the same fucking momentum. All answers easily and readily given without insults. You didn't say anything, jackass. What response will I get?
So yeah, that's tacked on there at the end, and it seems to me like, I don't know, it seems like maybe he didn't read this before replying. But yeah, this is pretty much what I expected. I have offered no insult. I've made no accusations. I was even willing to entertain that perhaps his hypothesis was correct, and started going down that route of like, what would that mean? How could we test it, etc.? And the response to that was, as you see here, just pure bile. Fun, isn't it? This is the world we live in.
Get a fuck you, because it's not an answer to the question. It's just arrogant, obnoxious, pontificating, childish, patronizing crap. How many times did you write, it's a Newton, it's a Newton, it's a Newton? Does it matter? Does it matter? Does it matter? No, it doesn't matter. Is it relevant? Is it relevant? Is it relevant? No. It's a quantity of energy, you fuck.
Newtons are not quantities of energy. Energy is defined to be force times distance. Work is defined to be force times distance. Work is energy. That's a definition, right? That's just a definition. Force is therefore not the same as energy, right? I mean, I hope that's not condescending or patronizing. I don't think that's insulting. That's just the definition. Anyone who didn't know that, there's no insult intended. Right? This is stuff we learn in physics class. If you haven't taken physics class or you don't remember physics class, that's okay, right? And just ask, right? Just ask. A force is measured in newtons. Newton is one of the units that we can use to measure force. But energy is not force. Energy is force times distance. So we're going to need a force unit like a newton and a distance unit like a meter. Or foot pounds. Foot pounds is fine. Newton meters is fine. Anything. But, it has to be a distance unit and a force unit. If you mix up your units, it can't be the same thing.
Shit. It's just so bad. Oh. All right. Yeah, this asshole did the same thing. Considering what you said about driving a car in the beginning, it seems that you still don't understand what kinetic energy means. It's magical fun to rub on your hiney energy. The kinetic energy of a car does not tell you how much energy the car consumes at that speed. Well, it actually does. Maintaining a speed isn't any different than accelerating to a speed.
Okay, this is someone else's comment now, but gosh, I'll respond anyway. This Bobby person is correct. No, the energy 1F mv squared is not the energy it takes to maintain a speed. It is the amount of energy that was put in to get to that speed. Maintaining a speed in a car means that you're constantly losing energy to aerodynamic drag, rolling resistance. So the rolling resistance and the aerodynamic drag are siphoning off your energy, and you have to replace it. So you have to continue pushing against, the wind to maintain your speed. I kind of thought everybody knew that.
News flash. Okay, because you're losing the energy to friction, you have to keep on putting more energy in.
Yeah, there you go. Yeah, we agree.
The air resistance and the friction keep absorbing it, and you have to keep putting it in.
Yeah.
Asshole.
Oh, see, why do we get the rude remark for an agreement?
It tells you how much energy was used to get to that speed. So again, it's just a lie that experiment in any way demonstrates anything. Okay, so go ahead. And I said right in my video, I said right here. I did state in another video, it doesn't.
He's not going to read it. I'm going to read it. I like this line right here from Bob. You are not just ignorant, you are aggressively ignorant. When people point out how you are wrong, you ignore it and refuse to learn. It's no wonder everything they say sounds like gibberish to you. So yeah, that's not my words, but they're good words.
Matter which experiment you do. 0 to 50 will not consume 25 times the fuel than 0 to 10. And you're an idiot, of course. All right, so he says it's no wonder everything you say sounds like gibberish to you. Everything they say, yes, of course. I mean, just, what's this horse shit? Again, theories existed for 350 years. Leibniz had no evidence. Deschardelet had a fake, flat earther experiment. And what else do they have?
I've heard the name Leibniz before. I don't really remember. The other name, I don't think I've ever really heard of it. Just want to stress again, that's not science. That's history. That's why when you hear somebody like this talking about how they think science is a religion, it's revealing that that's how they approach it. They're approaching it as a religion. They'll, read these old books and talk about old experiments that they don't like. And they usually follow it up with the just insane statement, no one's ever repeated that. No one's ever tried that again. And the truth is, if you look, it's hard to find. It's hard to find examples where people are doing these experiments. That's because they're trivial experiments at this point. The first one who did it, yeah, they're famous, right? They were famous at the time, at least. But now it's boring. We just do it in the classroom. It's just a classroom experiment now. It's not exciting, right? Because it's not a religion. These are not deities, right? Newton is not a deity. His writing is not the Bible. It's historical and interesting from a historical standpoint, and it gave us a lot to work from, and we've continued working from that, and we build upon it, right? We build upon it, and we don't read quotes from Newton's Principia. Is it Principia? Is it Principia? I've heard it both ways. We don't quote from that. The thing's written in Latin. Right? It's in Latin. So no, we don't do that. We teach the modern version of where we are today.
What's the other experiment? What experimental evidence proves the existence of kinetic energy? That's right.
I don't know. Go to the racetrack. Right? Go to the racetrack. Ask the car guys, how much horsepower is this thing? What's your 0 to 60? What's your 60 to 100? Right? They know these things. They understand why. Why is it easier to go 0 to 60 than 60 to 100? Why is it so hard to get to 200 miles an hour? Is it just because of aerodynamics, or is there maybe something else at play? Something about horsepower. I mean, we haven't even talked about power. We haven't even talked about power yet. What is power? How does power fit into this? Yeah, I mean, because you don't know. You don't know any of that stuff, but it's well known, well understood. You go to the racetrack. Those guys all know.
There isn't one. Fuck. I just hate this planet. Sucky, pukey humans. Yuck. They're all religious kooks.
Okay, so that's that. Let me sum it up. It's been a really long video. I don't know. I may edit it down a little bit. Just trying something new. Don't have the energy to do a proper prepared video with slides. My usual, slides and actual teaching of actual concepts. If anybody really wants yet another video on kinetic energy and momentum and that sort of thing, I could do that. If anybody wants to get together and come up with ways to do experiments on this, I could, at least when summer comes. Right now, in the middle of the semester, I'm busy, super busy. So just had time to make this, sit down and just watch this video and talk about it. Let's hear in the comments your thoughts if you have them. This is not. I don't need to tell you all this. If you're somebody who watches my videos, I don't want you to go to this guy's channel, frankly, at all. Don't go there and feed the troll. But certainly, don't be rude. Right? There's no reason to be rude. There's an example of where that leads. So that's why this is going up on my channel at all. Is contrast. This isn't how you treat people, right? The way draft physics treats this subject and treats anyone who interacts with him on the subject. It's gotten to the point where this is why he's on the internet. He's on the internet to find people to yell at. There is no discourse to be had. He's like a Nathan Oakley, right? He's like Nathan Oakley, only instead of flat Earth, he's going for kinetic energy, right? Whatever, right? Or John Mandelbauer with his angular momentum, right? Lots of people have this sort of approach to the world, and I do think there's an opportunity here to think about what does it mean to be a good person. I give that a thought. I'd love to hear comments like an interesting philosophical discussion. I'd love to have a philosophical discussion sometime. Maybe if a bunch of us ever get free time to do a live together, maybe we can talk about what does it mean to be a good person? Does lying indicate that you're a bad person? That's something that you'd think was non-controversial, but maybe it's not so simple. Right? Maybe it's not as simple as that. Does being angry and hateful make you a bad person? Does spreading anger and hate and vitriol to others, is going online and spreading hate, trying to stir up hate, does that make you a bad person? What makes a good person? Is it what is it? And is it the same thing for everyone? Is that a universal concept, or is it based on our individual sense of morality and all of that? Interesting questions. What is the appropriate way to respond to this kind of hate that we've just seen? The kind of hate that I just shared with all of you guys. What is the correct way to respond? I've always tried patient explanations, open-minded interaction, ready to take on their ideas and really give them a good try. Like, what if kinetic energy doesn't work? I'll start you right off. Then that spring experiment, right? That spring experiment that you mentioned and the one that I mentioned, those are great ways to test this. That should be the end of the conversation. We should do that experiment and then be the end of the conversation. I'll give you a second one. The regenerative braking or accelerating in a car, an electric car, would be decent ways perhaps to look into that. I'm a little nervous about the acceleration one because, okay, where was I? I was saying the acceleration question, the experiment of doing acceleration in an electric car. A little nervous about that one just because of the sheer amount of power that a modern electric car has. Maybe in the Prius. I was just driving a Prius earlier today. I got a Prius. I got a Tesla. In the Prius, the power is so low that we could do that. I mean, that would be very reasonable to do, like maximum acceleration rate from say 5 to 10 miles an hour, and then do that again, 10 to 15, do 15 to 20, all under pure electric power. And with the maximum power output, electric power output that the Prius can do, you could graph that, right? We graph that. That's pretty good. But if we tried that with the Tesla, we'd be spinning. Well, I guess it's got the traction limited. Maybe it's not going to spin, but now it's not pushing its full power, right? You're tire limited for those lower speeds. You could do it at higher speeds. Perhaps. But yeah, the experiment that draft physics suggests of like drain the battery, right? Or like measure how much battery you used in doing something. These batteries are huge. It would take quite a lot to make a visible dent in the battery. Maybe, I don't watch it while I'm driving very often, so maybe the power bar on the display would show us how much power we're using, and we could just film that. It's worth a try. But what I had mentioned was that I do notice the regenerative braking bar. There's a little bar on the display that shows how much power you're regenerating. This is true of the Prius. It's also true in the Tesla. What I've noticed is that at high speeds, that bar jumps right up. With just the slightest amount of regenerative braking, you can max out your regeneration. But then as you slow down, it gets to the point where you're slowing down pretty aggressively, and yet you're not generating any power. I think that'd be a really interesting thing to look at. If if there was any honest curiosity about this topic, that's what you do, right? Okay, so yeah, let's leave it there. I don't know. I mean, honestly, this is kind of why I've more or less stopped doing these videos. Part number one, I'm very busy with school. But part number two is what I've learned through all this is that people don't want evidence. They don't want the truth. They don't want evidence. They don't want to talk about it. They don't want to have a conversation about things. For the most part, they just want to yell. They just want to yell at someone and call them names and say that they're bad people. Yeah, and there you have it. This is an example, I would say the quintessential, typical example of the sort of person who is quick to engage with my material, material I haven't touched quite a while. This comes out of the blue, comes at you with this sort of bile, this vitriol. So yeah, that's kind of why I don't do it anymore. Okay, maybe someday I'll do some more. If anybody has something they particularly would like covered or would find interesting, happy to do that. I don't know when school's out, maybe in the summer again. So okay, I'll see you guys out there. Be nice down in the comments. You know the rules. This person is unlikely to be allowed to comment. I mean, he's not banned, but if he comments in any kind of way like what we saw in this video, that's not allowed, right? Name calling is explicitly not allowed. So I'll remind you all of that. It's not about that. Okay. See you guys when I'm back someday.